Hello once again. Today we're going to bring it all together. Water polarity, ions, ionic compounds, and see what happens when these things all meet together. The objective is this. So we know water is a polar molecule which has a positive charge and a negative charge, and that allows for water to attract anything else that's got a positive or negative charge. Water behaves like a magnet, and so ions have positive and negative charges. And so water can pull apart the ionic compound, and when it does, we call that dissociation or dissolving. We use that word all the time, dissolving. And so think about salt going into a glass of water. We stir it up, it looks like it disappears, but then if we taste it, we know it didn't disappear. Think about ocean water. It's full of dissolved salts. Or here's an environmental piece. A lot of pollution will have ionic charges. And so if rainwater runs down the street or through the lawns, anything it comes into contact with that has a charge, water can dissolve it, take it down the drain, and then where does it go? To the creek. And then in our case, to the bay. So there's an environmental piece, but even in your blood, ions are everywhere. Okay, here we go. One of my favorite cross-cutting concepts, and it's so hard to choose, I love them all, is structure and function. And this is begging to be called out in this example, because water, remember, hydrogen and oxygen don't share the electrons equally. This causes oxygen to have a slight negative charge, hydrogen a slight positive charge. That structure of the water molecule really dictates how it behaves. And so they can have cohesion with other water molecules, but then if we look at sodium and chlorine, here's my sodium, yours is red, mine's blue. It lost an electron to become stable, to fill out its shell. Lost an electron, it's +1 charge. Chlorine gained an electron, -1 charge. And now that structure affects how they can go together and make an ionic compound, sodium chloride. But what we're going to see is that's all, with water and sodium and chloride, it can all come apart. And so if you have this in your notebook already, great. If you don't, hit pause. This is going to be the notes for this lesson. Make this chart. What we're going to do is model how salt dissolves. We're going to look at a beaker of water. We're going to add salt to it, and then see how water dissolves the salt. We're going to draw pictures, and then we're going to explain what happens. And this will be on the assessment. We're going to model this, okay? And so hit pause, copy that down, and when you're done, here we go again. And so here's a visual for you. We're putting salt, sodium chloride, into this glass, and we stir it up. Here's what's really happening. We're going to put on our molecular glasses and imagine all those water molecules surrounding that crystal of salt. Remember, it's a repeating pattern of ions, sodium chloride, sodium chloride, sodium chloride. But what happens is the oxygen side of water, which is negative, surrounds the positive sodium ion and pulls it apart. And the hydrogen side of water, which is positive, surrounds chlorine, which is negative. Opposites attract. And because the hydrogen bond that the water makes with the ion is stronger than the ionic bond, it pulls it apart. And eventually, none of the crystal is left connected together. All the ionic compounds have dissolved. We're going to blow your mind here with a video inside of a video. This is pretty good. Check it out.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions.
Ionic compounds, crystals.
When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them.
Just like magnets.
Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
Pretty cool. I hope that helped you visualize it. And if it didn't, here we go. We're going to model it. I just so happen to have a beaker full of water molecules. We played with these in class a little bit. All right, I hope I don't spill. But so for part one of this, in this box, do your best to draw a diagram of the water molecules and label the hydrogen bonds. You don't have to draw this many, but draw that in. Now I'm going to take my salt crystal, my compound, sodium chloride, and drop it in. So you can draw a picture of that too. And then what starts to happen is the water starts surrounding these things. Uh-oh, I just spilled. It's okay. And the hydrogen positive surrounds the chloride, right? And then the sodium, which is positive, gets surrounded by the oxygens. I'm spilling water all over the place. So I hope that you can visualize that. And so some things like sand is full of ionic compounds, but if you put sand in a glass of water, it doesn't dissolve. Why not? Because the ionic bond between the sand ions was stronger than the pull of the water. But in this case, you can see the water is totally separated, the ions, the sodium ions and the chloride ions. So do your best to draw a picture of that here. And it's a hydrogen bond that forms between the water and the ions. When you're done, you want to do your best to explain what is happening in each one of these situations. And here's some great vocabulary for you. Hydrogen bond, polar molecule, cohesion, anion, cation. And I know I cheated a little bit here, but here is my picture of it with the water molecules. And I'm pointing out the hydrogen bonds and the sodium chloride in there that gets separated. And so do your best to draw those pictures and explain what's happening in there. And then also please fill out the Google Sheet so I know if you have any questions, and I know that you've watched this. And remember, this is our objective. Polar molecules dissolve ionic compounds. Okay, thanks for being with me, and I will see you next time.